Hello, this is Jonathan with ROBOTIS, and today I'll be speaking with Michael Dawson, Head Research Engineer of BLINCLab, a research lab for the University of Alberta in Canada.
It's great to be here. Thanks for having me.
It's wonderful. It's great to have you. So, to start off, would you mind giving our listeners a little bit of information on what it is that you guys do at BLINCLab?
Yeah, so our larger research lab is called the Bionic Limbs for Improved Natural Control Lab, or BLINCLab. And then BLINC Dev is the development open source community that we kind of spun off from that to take our most promising technologies and translate them into the community.
So, when you mentioned that some of the more promising technologies, what are some of the things you'd like to highlight so people have an idea of what exactly we're talking
Yeah, so we work primarily with persons with limb difference and developing technologies to improve how they can interact with the world. So some of the things we've worked on are like machine learning controllers to help control robotic prostheses, as well as sensory feedback devices that can help them feel what their prosthesis is feeling. Normally, they can only kind of see what the prosthesis is doing. And we work with all kinds of little sensors and motors and like integrating them all together into systems that we can test out new kinds of technologies on for them.
about? Oh, that's pretty awesome. Would you mind sharing what inspired you in specific to get started in a career in this sort of research robotics?
Yeah. So when I was way back in the day looking at what to do, I really liked robotics, but I also liked helping people. And there was kind of two streams. Like at the time, I was doing this like robo sub competition, and that seemed really cool. And I could do like autonomous robots, or I could become like a biomedical engineer, and then focus mainly on like modeling things on the body or working on medical devices and things like that. But I didn't realize you could kind of just like smush them together. So I had some professors that were like, "You should do both," and so I kind of focused in on that area for graduate studies and did a project on developing, uh, we called it a myoelectric, or like a muscle sensor driven uh, training tool for persons with limb difference for the above elbow level. And we actually, at that time, this was many years ago, I didn't design the robotic arm. We found this AX12 smart arm by Crustcrawler,
Oh,
which was one of the distributors of Dynamixel products from way back in the day. And so for the first several years, we used that actually as a research platform. Um, and eventually we kind of like ran into some limitations with that. And then that's how we like started developing our own robotic arm specifically for prosthetic research.
you specifically mentioned that it was an AX12 Dynamix alarm and that you started working down that path as you went on. Is there a particular reason that you ended up going with our hardware?
Yeah, so at that time, the main things like machine learning and sensory feedback, we were finding that the alternative for inexpensive hobby arms at that time was radio controlled servos, which you can send a position command to, and then it sort of has its own internal controller and it tries to get there the best it can, but you don't really know if it got there or not. You don't know any internal temperatures or loads or things like that. And when we're trying to teach our machine learning controllers to better interpret, you know, the intent of the person with limb difference, having every little bit of morsel of information is really important. So when we found that the Dynamixel series included those sensors built in, that was huge for us because it meant we didn't have to instrument all our own separate sensors separately onto the robotic prosthesis. And then also, even if we had done that, probably everything would have been analog. So you would have had, 3 wires running for this sensor all the way down the arm, 3 wires running for this sensor all the way down the arm. And then each motor would have had a couple wires also. And so the digital bus for the Dynamixel series really solves a lot of those wiring problems because everything can just run up and down the bus, and it works really well and has good support. and it made it easy for us to develop in that space.
Working so closely with these persons with limb difference and essentially putting these robots on their bodies, that safety is a big concern for what you're working with. Can you talk a little bit more about that and how developing something that people are actively wearing might be different from working in other fields of robotics?
Yeah, so going back to those like radio controlled servos or even industrial level servos, when you have to add in the safety as an extra step, um, for people who don't know how to do it or they're not aware of what's required, it can be kind of daunting, or they can just not realize that they're not doing it. So that's one nice thing with the Dynamixel actuators is that having the settings for we use the torque or the load settings a lot, like adding in limits. So we will make it so it's just strong enough to do what we need it to do, but not so strong that it will potentially cause like a safety issue. So things we're looking for are sometimes the control with the muscle signals isn't reliable, or it can become contaminated by, for example, like fluorescent lights. And if someone walks into a new area and then the arm starts like moving or like rotating and they don't mean for it to do that, um, or like like rotates into them or something like that, then you would want to set limits on that. So being able to set the positional limits is really, really important for us, so we can make sure that the robot doesn't intersect itself or the person that's controlling it, as well as setting those torque limits so that it has just enough to do what we need it to do, but not so much that it can cause damage or cause pinching or things like that. And then on top of that, because safety is so important to us, we also have different levels of kill switches or on and off switches that we can use. Even controlling the state of the motor is really useful. So in some situations, we might want to not necessarily kill the power to the entire system, but we want to turn the torque off on the motors. So we do that all the time too. We have like a mode in our software where we can turn off the torque and let the arm, for example, like free swing. Um, and so just generally in robotics, these kinds of features are much more useful when you're gearing towards this robot that's operating in the same workspace as the human.
Oh yeah, I can imagine that's a huge, huge difference. And you guys have gotten a good amount of exposure for some of the work you've done with your bento and mini bento arm and things like that. And it's also my understanding that you recently were featured on a pretty high-profile awards show, if I recall correctly.
Yeah, so we've sort of evolved. Like the original bento arm was very much like a desktop system, and we had played around with a little bit with it being wearable, but not too much at that time. Typically, if we were doing anything wearable, it was tethered. So we would run the power or the control signals like from a laptop that was sitting nearby. Um, and so more recently, we've gotten into looking at embedded controllers and battery operated systems. So for the bento arm, I was playing around with different kinds of battery systems. Uh, Recently, we've been looking at there's a pretty nice product that has like a 12-volt line and a 5-volt line built in. So
Oh,
for some of our other sensors, you can go in, and different kinds of embedded controllers and single board computers need those two different voltages. Um, so we had this opportunity actually to present at, it's basically like the Canadian Grammys. It's called the Junos. And one of our project sponsors, the Alberta Machine Intelligence Institute, Amy, was going to be presenting Rock Album of the Year with one of our professors, Dr. Pilarski. And so the organizational committee, they really wanted it to be delivered with some sort of robotic device. And there wasn't really like good options for power hookup on the stage. It was kind of a stage in the middle of a big like audience all surrounding it. So at the last minute, we like whipped up a totally wearable kind of we call it a simulated prosthesis. So it's like prosthesis that someone with limb difference would wear, but an able-bodied person is able to wear it. And so we whipped that up. And we used one of our robotic grippers called the Power Hand, which uses the MX64 actuator. And then we were going to use the OpenRB 150, which was like a really good option, but we ended up using the um, Arduino MKR
Yeah.
Wi-Fi 1010 with the Dynamixel MKR Shield. Uh, and so that was connected to this like battery system, and then it was all like mounted onto the forearm, and then we just had a simple joystick control for the live television, but ultimately we want to get it working with the muscle signals as well. So that's been something we've been working on since then, and it was a big hit. They were like shaking hands with the winners of the award and giving high fives and fist bumps and stuff like that. So it went over really well.
Yeah, that does sound quite awesome. But it also sounded like a perfect example of oftentimes when you're working in engineering disciplines like this, you get handed a problem that you might not necessarily know how to solve. And oftentimes that's where the fun in this comes. And in this case, sounds like your team did that perfectly. And I'm wondering if you have any other examples of, working with a difficult problem, something you're not quite sure how to solve, and how you guys managed to work your way out of those.
Yeah, so we're always having to pull stuff out of our hats. Stuff comes down the tubes, and we don't have much time to like get things going. Um, some of our early work that we did with the bento arm and handy hand. So the bento arm at that time, we released it open source like quite a long time ago, like maybe in around 2014, 2015. And then the handy hand was a few years after that. And at that time is using radio controlled servos, but now we're looking at upgrading to XL330s in the Dynamixel line. But to try to get these open source pushes going, we're coming from engineering backgrounds, and we're not sure exactly like how to put all these things together and release it to the public. And we were going to these Maker Faire conventions, which had been discontinued for a number of years. But actually, I heard this year, actually for the first time in many years, they ran it again in the Bay Area. So that's really exciting to hear. So we had these like conventions that we would go to, or we would go to conferences and want to build like a demo or something. And so it was really, really common for us to be like, the night before, and I'm like, coding the software that we're supposed to be using the next day. And like we were like making like, this is an actual like nice t-shirt, but we were like iron on transferring t-shirts, and I was printing off like business cards in the lobby of the hotel, and we had like a soldering iron. Like we walked in and we had these like arm shells that were based off of a 3D scan of my arm that go onto the bento arm, and we like pick it up out of our Pelican case, and it hits the ground and breaks all apart. So we're like
Ironing the
super
pieces.
gluing things back together, and that was sort of, you always have to expect things to go wrong. And it's we treat it kind of like a space mission when we're doing these kinds of events. We have like a checklist, and these are the things we need to prepare and everything we need to bring, and then you actually have to go through and check them off so you don't forget things. And then but still things go wrong, and you have to improvise at the last minute.
Got to be good at thinking on your feet. That's just how these things work out.
Yeah, exactly.
Yeah, and speaking of events and things like that, I know recently you guys held a bento and mini bento Olympics to sort of promote the adoption of your platform, to give people a chance to test what was going on and see how they're working. Would you mind talking a little bit about that?
Yeah, for sure. So the mini bento was sort of, we'd gotten this feedback. The quite a few other research groups, labs, hospitals. We've also translated the bento arm system into hospitals. Lots of people were using the full size bento arm system, but when we were going to these maker fairs and things like that, hobbyists we were getting some feedback that it was more than what they were looking to use for, say, like educational purposes. And so they were like, oh, could you build one with like radio controlled servos that would be less expensive or smaller or something like that? And so I was really excited when the smaller
Uh,
X series servos came out,
or
that
330
we
size.
kind of like, yeah, the XL 330s, because that opened up a lot of doors for what we could kind of do in that space of like miniaturization. And so yeah, I looked at like how small could I make this, and the the way it worked out with the size of the motors is I could get down to 1/3 scale, and make this like pretty fun little arm. And so nominally, maybe we might be able to use it for take home training for persons with limb difference. They come to the clinic, they train with the bento arm system using muscle signals, but there's also like these little muscle sensor bands that they could take home. And if there was a small enough robot or a virtual robot, they could maybe train at home. But what we use it for mostly so far is education purposes. So kind of any age group that's looking to pick up a little bit about robotics, or about prosthetics, this is like a really great platform to try that out. So I've got one of the prototypes here, and there's a fun video that we can share with you guys too to check out. So this one is battery powered, and it can also be powered from wall power.
That's pretty neat. I don't think I've ever
So
actually.
it's so much fun.
Yeah. I haven't seen one in operation before, and it's quite nice seeing it. I didn't realize everything was so tightly integrated into one platform like that, with the thumbstick right on the
Yeah,
same plinth and everything. Very elegant
yeah.
design.
So a lot of the robots that we've seen, there's other small kits that you can get, but they tend to be always desktop mounted. Um, and so this one is, I think, maybe one of the first handheld ones I've ever seen, that you can actually hold it in your hand like a video game controller. And so this really opens up the door. So when we were doing our workshops, our educational workshops, we were looking at how can we, make this fun. So you're learning about building it, but then maybe you actually play like games with it. In the same way that you could play video games, you could make up little tasks and things to do. So we had one that was basically like a plinko game, where you would grab some kind of like object, and like a little ball, and then there'd be like a ramp with a bunch of cups, and the cups would have different point values, and so you'd have to like line up, where you were going to go, and then there's all these little things it bounces off of, and then you would release it, um, and it would roll down the thing, and then people would get points and get excited about it. We've also had people play like Pictionary.
Oh,
So we kind of like in the workshops, we broke people up into teams, and then they would try to draw things for each other. And if they got it or not, they would get a point. And if not, then they didn't. There's all kinds of little like speed challenges. So um, grabbing different objects and then putting them in other places, you can do as like a speed challenge. Same thing as like time trials for video games. And then at the end of the day, we had like we built like a little podium for them, so the different teams got a certain amount of points in each event, and then we 3D printed little medals for their mini bento arms.
oh, that's extremely cute. And I'm sure that this was a great learning experience for your team and the children, and you took some things sort of about the functionality of the device and its design. Was there anything in specific that you learned through these tests?
Yeah, so we everything that could go wrong does tend to go wrong. Luckily, compared to some of our earlier prototypes, very little did we have issues with. There's like the common, it's not common, but if you put like the wrong screw in the servo housing, it can damage the housing. So we had like one servo out of like uh, like 100 that were damaged that way, which is actually pretty low. And then immediately I was like, oh, I need to add a diagram in the assembly documentation to help call out this issue and make sure it doesn't happen again. Um, some of the some people had trouble with the wiring aspect of it. So there was like the open RB 150 here that just sits in the base here. It's nice to have it kind of like enclosed and so that it's like um, hard to like snake out the wires and things like that. And we have little shields that can go over this and stuff too. But that also made it hard for people to experiment with the Arduino. So one of the changes we made was we added like access holes in the bottom to make it easier to pull these two pieces of the base apart so that you could quickly disassemble it if you want to do some more advanced Arduino stuff with it.
It's important
So
to,
those are some examples. Yeah.
yeah, redesigns are an important aspect of something like this. So, where's the future of Blink Dev heading? I mean, it seems like you guys have put a lot of work into designing your bento and mini bento platforms, and those are more or less proven technology at this point.
Yeah. So the big step for us coming up is so in addition to the mini bento, we're also looking at revamping the handy hand, which is a multi-articulated hand using the XL330s. And the big push is all towards wearable. So some of that stuff that we did at the music awards earlier this year, we want to take what we learned there and apply it to this international competition called the Cybathlon. And so it's sort of like a bionic Olympics where they have prosthesis users, upper limb or lower limb. They have wheelchair users, um, all these different kinds of people that are using these different kinds of devices, and then but they build like a competition around it, and it's to help build assistive and rehabilitation technologies and take it to the next level. So it's like they've got like commentators, people are wearing like jerseys. They have these set kinds of competitions that you can sign up for and compete in. So we're going to compete in the arm prosthesis competition. And we're going to take the bento arm and fully make a wearable platform with it, including integrating the muscle sensors and make something that our pilot, a person with limb difference, can wear and compete with.
This sounds like a great way to push forward with the future of your bento platform. You mentioned a few times other limb differences. Has your team worked on anything else other than upper limb prosthesis? Do you have any other things in the works?
Yeah, so our lab, we work on both upper limb and lower limb prostheses. And so one of the areas that that we also work is in sensory feedback. And so for both upper and lower limb. And so this is an area where, you want to be able to feel what the prosthesis is feeling. And so some of the tasks in the Cybathlon require like haptic feedback. And so you have to like reach inside of a bag and try to grab certain objects that you can't see. So that's really kind of like challenging us to integrate some of these technologies that we developed in the past. We're particularly excited about the XL330s with the integrated position feedback because um, uh, they normally were instrumenting like potentiometers everywhere and having to run all of those wires. So it will save us like so much wiring if we can get some kind of indication of the position of the hand using the integrated encoders. Um, and then another initiative we've had in the lab over the last few years for lower limb specifically is called osseointegration. And so that's instead of putting a socket, like a kind of like a plastic shell around the residual limb and using suction or harnesses to hold on the prosthesis, you can also use, there's some new emerging technologies where you can implant a metal abutment into the bone and then it comes through the skin and then you can attach prostheses to that directly. So we've done that for lower limb, and now we're excited to maybe challenge to look at doing upper limb as well. And that opens up possibilities to make it easier to integrate and to attach things. But it has its own set of challenges that obviously we would need to figure out as well.
Yeah, that sounds like it's right on the cutting edge of basically all assistive and medical technologies right here.
Yeah, so we've got our Blink Dev website, so please go check that out. We should be having, I hope the mini bento arm might be released open source later this year or early next year. We're still working on the documentation, but if you really want to try it, contact us and we can get you the beta documentation if you want to try building it. And yeah, check out our YouTube channel. And I think we also have a Twitter now.
Oh, awesome. I'll be sure to share the links for all those things in the description below. This has been Jonathan with ROBOTIS, presenting an episode of ROBOTIS Talks featuring Michael Dawson from BLINCLab, and I look forward to speaking with you maybe sometime in the future.
Awesome. Yeah, let's keep in touch.